In the vast, silent expanse of space, something extraordinary happened. Astronauts, floating in the cold void, picked up whispers from a nebula, sounds so faint they defied detection. These weren't just any sounds, they were voices, echoes from a cosmic lullaby sung by the universe itself. What were they saying? How did they get there? And why does this matter to us, back on Earth? Buckle up, because we're about to dive into one of the most haunting and beautiful mysteries of the cosmos. This isn't just a story about space, it's a story about us, our place in the universe, and the secrets that lie just beyond the reach of our everyday senses. So, are you ready to listen to the whispers of the stars? In the vast, silent expanse of space, astronauts aboard the International Space Station, ISS, have been picking up faint, unusual sounds. These sounds aren't your typical space noises, like the hum of machinery or the static of radio communications. Instead, they're subtle, almost imperceptible patterns hidden within the background data. This data is collected from various sensors and instruments monitoring the station's environment and systems. Astronauts first noticed these faint patterns while reviewing processed background data. They were looking for anomalies or irregularities that might indicate potential issues with the station's equipment. The data is typically analyzed using sophisticated software that can pick out even the smallest deviations. It was during one of these routine checks that astronauts first heard the whispers. They were so faint that they were barely audible, even when amplified. At first, the astronauts thought they might be hearing things, a trick of their ears or the equipment. But the patterns persisted, consistent and eerie. The sounds were described as faint, whisper-like voices, almost like distant conversations. They were not clear enough to make out any words, but they were unmistakably there. The astronauts were baffled. They knew that space is a vacuum, a place where sound shouldn't exist. So, how were they hearing these whispers? The answer lies in the way the data was being processed. The sensors on the ISS pick up a wide range of frequencies, including some that are inaudible to the human ear. When this data is processed and converted into an audible format, it can sometimes reveal hidden patterns. In this case, the patterns sounded like whispers. The astronauts weren't the only ones intrigued by these mysterious sounds. Scientists back on Earth were also puzzled. They began to investigate, running tests and analyses to try to understand the source of the whispers. They found that the sounds were not coming from any external source, like a distant planet or star. Instead, they were a byproduct of the data processing itself. The software was picking up on tiny fluctuations in the data and amplifying them, creating the whisper-like sounds. It's a bit like how a radio can pick up static and, under the right conditions, turn it into something that sounds almost like a voice. In the vast, silent expanse of space, astronauts have made an intriguing discovery. They've found that voices can be recorded far below the normal detection thresholds of their equipment. This finding is a result of advanced frequency analysis techniques. These techniques allow scientists to pick up structured signals that would otherwise go unnoticed. Frequency analysis is like a detective's tool. It helps scientists find hidden patterns in the noise. In this case, the noise is the constant hum of space. The structured signals are the voices of astronauts. These voices are so faint that they're below the usual detection limits. Yet, with the right tools, they can be heard. The key here is understanding what's meant by below the noise floor. The noise floor is the measure of the signal created from the sum of all the noise within a system. It's like the background murmur in a crowded room. Normally, any signal below this level is considered undetectable. But advanced frequency analysis can dig deeper. It can find structured signals, like voices, that are buried in this noise. For instance, consider the sound of a whisper in a noisy room. To the average person, it's inaudible. But with a sensitive microphone and some clever analysis, that whisper can be isolated and understood. This is similar to what's happening with the astronauts' voices. The signals are weak, but they're not random. They have structure. And that structure can be identified and interpreted. The Whispering Nebula is a fascinating cosmic structure, characterized by its unique environment. Gas density here is remarkably low, with atoms and molecules spread far apart. This sparsity allows light to travel great distances without scattering, creating a clear, almost ethereal view. However, this doesn't mean the nebula is empty. It's filled with various gases, primarily hydrogen and helium, along with traces of heavier elements. These gases are not uniformly distributed. Instead, they form intricate patterns and filaments, shaped by stellar winds and radiation. Radiation levels in the Whispering Nebula are significantly higher than in the void of interstellar space. This is due to the presence of hot, young stars within and around the nebula. These stars emit intense ultraviolet radiation, which ionizes the surrounding gas. This ionization process causes the gas to glow, creating the beautiful, colorful displays often associated with nebulae. The radiation also contributes to the nebula's dynamic nature, driving complex interactions and phenomena. One of the most intriguing aspects of the Whispering Nebula is the unusual ion interactions that produce harmonic patterns. When ions collide or interact, they can emit electromagnetic radiation. In the Whispering Nebula, these interactions often result in the emission of radio waves. These waves can sometimes form coherent, harmonic patterns. This is unusual, as random collisions typically produce a broad spectrum of frequencies. The exact mechanism behind these harmonic patterns is still not fully understood. It's thought to involve complex feedback loops and resonances within the nebula's magnetic fields. These harmonic patterns are what astronauts have reportedly recorded as voices below the noise floor. The patterns are not actual sounds, but when converted into audible frequencies, they can resemble whispers or murmurs. This phenomenon adds a layer of mystery to the Whispering Nebula, making it a subject of ongoing scientific interest. The crew of the International Space Station, ISS, first noticed the whispers during a routine mission. At first, they thought it was just static or interference, but the sounds persisted, faint and indistinct, lurking just below the normal range of human hearing. The astronauts, trained to remain calm and logical, initially dismissed it as a technical glitch. Yet, the more they heard it, the more unsettling it became. Silence fell over the crew as they tried to process what they were hearing. It wasn't just the strangeness of the sounds that got to them. It was the way they seemed to fluctuate, almost as if they were trying to form words. The astronauts, usually a chatty bunch, found themselves speaking in hushed tones, as if afraid to disturb whatever was causing the whispers. They started to feel a creeping sense of unease, a tension that hadn't been there before. It was like having a ghost in the machine, an unseen presence that they couldn't shake off. Attempts to isolate the sounds only added to the tension. The crew tried everything, from adjusting the radio frequencies to checking the life support systems. They even considered the possibility of a malfunction in their communication devices. But nothing they did could pinpoint the source of the whispers. The more they tried, the more frustrated and anxious they became. Sleep became fitful, conversation strained. The usually tight-knit group found themselves on edge, each member hyper-aware of the faint, eerie sounds that seemed to follow them wherever they went. It was a strange, unsettling experience that left them feeling vulnerable and exposed, despite the safety of their high-tech surroundings. Terrestrial scientists have been baffled by their inability to replicate the whispering effect recorded by astronauts in the Whispering Nebula. The phenomenon, where voices seem to be heard below the noise floor, has not been successfully reproduced in ground-based laboratories. This failure raises questions about the unique conditions in space that might be contributing to this effect. One of the primary challenges is the vast difference between the space environment and Earth-based labs. In space, the vacuum of the Whispering Nebula provides a near-perfect medium for certain types of sound waves to travel. On Earth, even the most advanced laboratories cannot fully replicate the vacuum conditions found in space. Atmospheric pressure and the presence of air molecules interfere with the propagation of sound waves, making it difficult to achieve the same whispering effect. Efforts to simulate the conditions have involved using vacuum chambers and advanced sound dampening technologies. However, these attempts have fallen short. The subtle nuances of the space environment, such as the presence of cosmic dust and the influence of magnetic fields, are hard to replicate accurately. Scientists have tried adjusting various parameters, but the whispering effect remains elusive. This highlights the complexity of the phenomenon and the need for further research. Another hurdle is the sensitivity of the equipment used in space versus that available on Earth. Astronauts' recording devices are often more advanced and specifically designed to capture faint signals in the harsh conditions of space. Ground-based equipment, while sophisticated, may not have the same level of sensitivity or the ability to filter out terrestrial noise effectively. This discrepancy makes it challenging to compare the data collected in space with that obtained on Earth. Until these issues are addressed, the mystery of the whispering effect will likely persist. Long-range sensors have been a staple in space exploration for decades. They're designed to pick up faint signals from distant objects. Early missions, like the Voyager and Pioneer probes, carried these sensors. Their primary job was to study planets, stars, and other celestial bodies. But they also picked up something unexpected: faint, unexplained audio anomalies. These anomalies were often buried deep in the data. They were so faint that they were barely above the noise floor. The noise floor is the level of background noise in any system. In space, it's incredibly quiet. So, even the faintest signals can stand out. Yet, these whispers were often overlooked. They were dismissed as interference or instrument noise. Comparing data from older missions reveals a pattern. Similar anomalies have been detected in various missions. For instance, the Cassini mission to Saturn and the New Horizons mission to Pluto both recorded faint, unexplained sounds. These sounds were never fully investigated. They were often buried in technical reports. Only a few scientists noticed them. The reasons for not reporting these anomalies are complex. One reason is the sheer volume of data. Space missions generate massive amounts of information. Analyzing it all is a monumental task. Another reason is the focus on primary objectives. Scientists are often looking for specific data. Unusual sounds might not fit their criteria. Additionally, the faintness of these signals makes them easy to overlook. They are often lost in the noise. Despite this, some scientists have taken notice. They've started to compare data from different missions. They found striking similarities. The sounds are often in the same frequency range. They also share similar patterns. This suggests that they might be caused by the same phenomenon. However, without further investigation, it's hard to say for sure. The Whispering Nebula phenomenon has sparked renewed interest in these old datasets. Scientists are now revisiting them with fresh eyes. They're hoping to uncover more about these mysterious whispers. Engineers and researchers have been engaged in a lively debate about the nature of the Whispering Nebula signals, particularly focusing on digital artifact theory. This theory suggests that the voices recorded by astronauts could be the result of compression errors or corrupted data packets during transmission. The idea is that when digital signals are compressed to save space or bandwidth, some data might be lost or altered. This can create artifacts, or distortions, in the final output. In the case of the Whispering Nebula, these artifacts might have been interpreted as voices. Some engineers argue that the signals could have been corrupted during their journey from space to Earth. Data packets can get scrambled or lost due to various factors, such as interference or damage. When these packets are reassembled, the resulting data might not be accurate. This could lead to the creation of sounds that resemble voices but are actually just noise. For instance, a corrupted packet might introduce a sudden burst of sound or a glitch that, when played back, sounds like a whisper or a murmur. Others, however, are not so quick to dismiss the voices as mere artifacts. They point out that the signals have been recorded multiple times and under different conditions. If the voices were simply the result of compression errors or corrupted packets, it would be unlikely for them to appear so consistently. Moreover, some engineers have noted that the voices seem to follow certain patterns or structures that are characteristic of human speech. This has led them to believe that the voices might be genuine, even if their origin remains a mystery. The debate is further complicated by the fact that digital signals can be affected by a wide range of factors. For example, the equipment used to record and transmit the signals can introduce its own set of artifacts. The environment in which the signals are recorded can also play a role. In space, for instance, there are many sources of interference that can affect the quality of the signals. Engineers have to take all of these factors into account when analyzing the data. This makes it difficult to definitively say whether the voices are real or not. Until more research is done, the debate is likely to continue. Deep within the archives of space exploration, a trove of classified audio samples has remained largely untouched and unheard. These samples, mentioned in internal documents, were recorded by astronauts during missions to study the Whispering Nebula. The audio files, captured below the noise floor, contain sounds that are inaudible to the human ear under normal circumstances. Scientists had to use specialized equipment to amplify and analyze these faint signals. The recordings are not just random noise. They exhibit patterns and frequencies that have puzzled researchers for years. The internal documents reveal that the astronauts described these sounds as eerie and otherworldly. They noted that the whispers seemed to come from all directions, as if the nebula itself were speaking. The recordings were so unusual that they were classified to prevent public speculation and panic. The documents also mention that the sounds changed over time, suggesting that the nebula is not a static entity but a dynamic and possibly sentient one. This has led to a lot of debate and speculation within the scientific community. One of the most intriguing aspects of these audio samples is their potential to reveal new information about the universe. The sounds could be the result of natural phenomena, such as cosmic winds or magnetic fields interacting with each other. Alternatively, they might be something more exotic, like the vibrations of dark matter or energy. The classified status of these recordings has made it difficult for independent researchers to study them, but the internal documents provide enough detail to spark curiosity and speculation. The possibility that these whispers could be a form of communication from an unknown source has captivated the imagination of scientists and enthusiasts alike. The internal documents also mention that the astronauts reported feeling a sense of unease while listening to the whispers. They described it as a feeling of being watched or observed. This psychological impact has been noted in the documents, but it has not been widely discussed or studied. The classified nature of the recordings has limited the ability of researchers to explore the psychological effects of these sounds. However, the documents suggest that the whispers had a profound impact on the astronauts, who reported feeling a mix of awe and dread. This raises questions about the potential psychological effects of exposure to such phenomena and the need for further study. As we wrap up our journey into the enigmatic Whispering Nebula, let's recap the incredible findings that have left scientists and space enthusiasts alike buzzing with excitement. Astronauts have picked up mysterious voices hidden beneath the usual hum of space, a discovery that challenges our understanding of the cosmos. These whispers, though faint, hint at phenomena we are only beginning to comprehend. It's a reminder that the universe is vast, full of secrets waiting to be uncovered. Imagine the thrill of being part of this cosmic mystery. What if these whispers are messages from distant worlds, or perhaps echoes of cosmic events we've yet to fully grasp? The possibilities are as endless as the stars themselves. We are standing on the brink of a new era in space exploration, and you, our curious viewers, are right here with us, sharing in the wonder and the discovery. So, what's next? Stay tuned, because we are diving deeper into the unknown. Future episodes will explore the latest theories, the cutting-edge technology helping us listen closer, and the bold missions aiming to unravel these celestial whispers. Don't miss out on the adventure. Subscribe and hit the notification bell to join us as we continue to explore the mysteries of the Whispering Nebula and beyond. Together, let's keep our eyes on the stars and our ears open to the universe's secrets. See you in the next episode.